This is digital LIGHTWAVE sales training for internal use only. This is the subject of the NIC platform and the PDH TCarrier features. So good morning, everybody, and I hope you know the ones of you who have been here before. I don't think I have anybody here today who's never been here before. Nope, I think all of you have been here before. But please ask questions anytime you want. We'll just be addressing questions as we go along. It's a very informal class. I did not actually prepare a curriculum. I'm just going to look at we're going to look at the data sheet, and then we're going to look at the an actual NIC running PDH and TCarrier, and I'll show you some features and show you how to demo it and give you the key selling features, and I'll answer your questions, and we'll be all done. So here we go. First thing I want to look at is the data sheet. Now, this is a new data sheet. It's actually under construction, which you will see in that there are some blank spots in it, which is all the marketing fluff that needs to be in here. New data sheets always have a paragraph about why the particular modules are so cool. That's the fluff is not done on this one. Most of the key features are done, but those will be modified just a bit. I think there are a few things I saw yesterday I needed a little bit of work on. Maybe not. Well, there we go. Yeah, that's still okay. Anyway, I want to get right to a couple things. I want to mention this repeatedly. There are only really about two key features about our PDH and TCarrier that make it better than the competition. The trouble with PDH TCarrier as a feature is it's sort of a commodity feature. Basically, every one of our competitors also has a PDH and TCarrier. DS1, DS3, E1, E3, and E4. Some even have E2. That's a less common. It's a less common interface, but it is still used, and some test sets have that. So it's hard. It's a bit hard to differentiate ourselves in the PDH TCarrier world. We can do. Here's an important part. It's right on the top of the data sheet. It's multiple simultaneous PDH and TCarrier testing. And if I go down here, where's my list? Well, we'll go with this list. So 1.5 meg is DS1, 2 meg is E1, 34 meg is E3, this is 45 meg is DS3, and this is E4. Our module will do 2 of these tests, either 1.5 meg or 2 simultaneous. It will do 1 of these tests, either E3 or DS3, depending on how you configured it, and an E4. So that's 4 simultaneous tests with that one module. And they're simultaneous, completely independent. Each gathers its own results. Start it, stop it independently. That is a selling feature. I don't know how huge of a selling feature it is, but it's definitely a selling feature you should know, and you should always tell people if you are if you're demonstrating to them PDH TCarrier features. Okay, and let me see. I'm gonna look for questions. No. Is there any question just on the terms themselves, on PDH, what PDH is, or TCarrier? We kind of use it. We throw these names around a lot. I mean, they really just mean TCarrier is more of a U.S. term, and PDH, or Placeochronous Digital Hierarchy, is more of a outside the U.S. term. And it really just means those rates that I hope you're all familiar with. As I said, DS1, DS3, E1, E3, and E4. Now somebody... Okay. I got a comment that says, yes, the buzzword material is historical and rather opaque. Okay. So we won't worry too much about that. And I want to go right into our other, it's going to be featured here, it's going to be in the marketing part of this, is our other good feature is being able to drop and insert all the PDH rates from a Sonnet rate, or even from an OTN rate, a higher rate. In a NIC Plus, we can even drop any of these rates all the way down from 40 gig in that one NIC Plus module. Oh, sorry, in that one NIC Plus chassis. You're going to see there's going to be a little bit of a diagram over here as well. Jitter Wonder actually is not going to be on this data sheet. There's going to be a diagram of drop and insert. I'll tell you a little more about that on the test set itself. It's a little more easy to see. So the rest of the data sheet really consists of, so there's the first page and our key features. Let me run through the rest of the key features. So it has all those separate interfaces, meets the requirements of these, meets these international requirements, as our competitors do as well. Drop and insert from Sonnet SDH with NGMR or OMR modules, so that needs to be updated. It should say MSA modules. Multiple simultaneous testing with an all test status screen, which I'll show to you. ATM mappings, if equipped with that module. Dual DS1E1, so each of these PDH modules has 2 ports for DS1 and E1. And while we're on that dual DS1E1, there's one thing I want to show you. I don't know if I can actually make it large enough for you to see without being out of focus. Maybe a bit out of focus. But hopefully you can see it. There are, I'm going to draw a circle around here. There's this port. There is this port. This is an actual picture of a faceplate from a module. And it has, see, this says E1 DS1 number 1, E1 DS1 number 2. Note that one of them is a BNC type connector, 75 ohm, and the other one is a Bantam type connector. It's balanced. It's the kind that these are 2 holes and it plugs inside of them. So even though you have 2 E1s or you have 2 DS1s, they're going to be on this different physical interface. Customers are sometimes a little bit confused about that. I'm not quite sure why we've done it that way, but we did, and that's the way it is now. In some cases it's not terribly useful because in the U.S. we mainly see this type connector, and if they want to use 2 E1s, they want to use 2 of these. So they don't want this one and this one. And the rest of the world, sometimes you'll see this type connector, and again, they don't want to use one of those. So the solution, the way around, is we can sell them adapter cables. We have an adapter to take these over to the 100 ohm or 110 ohm Bantam like this, and we have adapter from this one to that. So if you're in the U.S., your customer can use one of these and then this port with an adapter. Same thing for Europe. So they really can use 2 ports. It just takes an extra device that we can sell them. Okay, hope that makes sense. Let me try to turn my drawing off. Okay. And I'm going to have a quick check for questions. The question says, what are some of the other key terms they should be looking for? TDM, T1, TCarrier, etc. That may have wrapped it all up. T1 and T3 are another term really for DS1 and DS3. Technically they're not the same, but they're used interchangeably. TCarrier is pretty common in the U.S. or DS1, DS3. Over outside the U.S., I'm not really familiar with any other terms other than PDH and E1, E2, E3, and E4. And we do hear TDM, time division multiplexing, which applies to all these rates. It also applies to Sonnet SDH and applies to OTN. It applies to pretty much everything we work with except ATM and Ethernet and fiber channel. So I don't know any other terms that people should be looking for when you're looking for opportunities. I'm going to do a little work on the website now, so we have all these terms and meta tags and words on the pages so that people will find this when they're looking for test equipment for PDH and TCarrier. Okay, I'm going down to more of my data sheet here. I did this one. And these are getting into more common features of the NIC. We just sort of put them in key features. Event logs and graphs for long-term testing and analysis. That exists also in our Sonnet and OTM features. Investment protection, existing NIC products can be upgraded. That's pretty much always a selling feature for NIC platform. And easy to use NIC graphical user interface and 24-hour tech support. All common features. And then the data sheet has some pictures of what the GUI looks like. And you can show, I'm not going to show you here, I'll show you on the actual test set when I'm doing the demonstration and showing you how to demo. You'll see these similar screens, and then you'll be able to, if you're just showing someone a data sheet, you can point out useful things here, but I'm not going to show it here now. I'll show it on the test set. And we get into the interface specifications for all the different rates. And then these are connectors. Just as I was telling you, it's important to understand these connectors for DS1 and E1. DS1 E1 Bantam, DS1 E1 BNC, one of each. They can't have two of each except for the adapter. And you get into here all the specifications of all the patterns you can do and so forth. These are, to a large degree, these are just commodity. Most of our competitors are going to have exactly the same feature set. I don't know of anything within these features that make us really unique. It's the drop and insert features and the multiple simultaneous. Okay, we'll get down here. That was the final page of the data sheet. It says jitter and wander testing specifications. So there are two modules available, two modules that we call PDH TCarrier. An A11 is all the rates without jitter and wander. And the A14 is all the rates exactly the same plus jitter and wander. That's really the only information you need to know in ordering. There are no other options. There's one software option, a test option. License-based is wander measurement, which goes only with this one, only with the A14 module, the jitter wander. Okay, and one new little feature on the data sheet I want to let you know for those of you who are distributors. On the data sheets now, we just reconfigured them a little bit so that on the last page there's a space here that you can actually add. You can make a little sticker and put your information on there and hand this to people, or we can, I can make, or your own people can make an electronic version that has your contact information right here. But you might find that useful. And we'll sweep back to the first page, and then also on the first page, on the bottom of every data sheet, there'll be a space. Like all this will be blank, a rectangle about that size. And again, that's for your. You can put your logo, Digital LIGHTWAVE, represented by a certain company in a certain region, that sort of thing. And also up here, I want to point out how I said there's the A11 without jitter and the A14 with jitter. And I want to point out that they are about the same. The only difference is this one port. You can immediately tell a jitter one by this demod port. Demodulated jitter port. And I'm not really prepared to talk about jitter today. I'm not the jitter expert. That would be Jeff Adams, and he's not here with us today. Okay, so I'm going to take a peek, quick peek for questions, and then we'll go right to the test set. And I have a couple. It's a good question. Can any particular types of customers or types of applications be named that require the two simultaneous ports? Well, often in the carrier world, in troubleshooting, I know our customers like to look at two directions at the same time. They'll want to see traffic coming from the east, traffic coming from the west, where they are, and look for errors at the same time. So that's one obvious application. Another is, I would believe, in manufacturing, where you're qualifying a piece of equipment that they've manufactured. They want to see if it's going to be good. The more ports they can do it simultaneously, the better. Those are the two applications that come to mind. You folks may be able to answer that better than I do. So if anybody has a good other application for dual ports, just let me know. That would be fine. And Okay, somebody asked any reason talking about the A14 with the wander analysis. Now, I do want to point out, let's go back down here to it again. I may have put something wrong on the data sheet that caused confusion. No. So there is, the A14 is jitter generation analysis, and the test option is wander. So this is jitter, and when you add the test option, it'll do jitter and wander. Jitter and wander are basically the same thing. It's just a matter of the time period of how quickly or how long they take. The module itself does jitter analysis. Wander analysis is actually done by a client, actually a program that runs on the PC. It has to look at the results over a longer period of time. So the test set itself is not capable of calculating all that. Alrighty, so now we're going to go, I'm going to close this out. We're going to slip right over to the test set itself, if I can push the right button. Good, and you should see that. So I'm going to run through, I'm going to pretend you all are customers. I'm going to run through what a demo is like. Hope that's okay. And I don't see any other questions. Let's see if I can get this up so I can see the questions at the same time. That would be clever, just in case you have any. I'll see them right away. Okay, first thing I'm going to do, it's a demo. I know I do this every time. I know you're bored with this, but I'm going to tell you every single time. Go to System, Restore to Factory Defaults. You know, you just can't go wrong with Restore to Factory Defaults. Pick any one, pick whichever one is applicable to your region, and you just let it do it, because that'll prevent so much difficulty. And just any possibility that you've set something up a little unusual and take you a little while to find may kind of mess up your demo. Could even cause you to lose a sale if you don't know what it is. It makes us look bad if we have to do reset to defaults after. But if you do it at the beginning, you just say, well, you know, so it's a known state because I may have messed something up earlier, then you're good. Okay, so now we have the default I chose was, I kind of made a combination. I wasn't really paying attention to what I did, but I did the E1s on the low speed, DS3, and then E4. You can't have these combinations. Yeah, I chose that one. I don't think that's common in any region. For North America, I think you're always going to choose Sonnet DS1, DS3. And for Europe, Asia, most of it anyway, I think you're going to choose SDH E1, E3. Okay, we'll just leave it the way it is for now. And then, so I have all these tabs. And each of these, as I've said before, are independent and simultaneous. They never have anything to do with each other. I cannot, I cannot run a test from this one to this one or anything like that. They're all completely independent, simultaneous. And let's start with the lowest rate. We're going to go down to E1 number 1. And because I'm using remote control, I have to click this little lock button, lock and exit. So I'm actually using this test set. And this is laid out as our other test sets are. The left side is alarm and status indicators. It tells me I have a green light now, means I have a good frame here, and I have a good pattern sync. I'm sending a pattern that's already set up basically from the default. I didn't set this up. We just did the default, and that's the way it is already. There is a loop on this E1 port number 1. And across the top here, we have a series of buttons. Transmit, everything that has to do with our transmit signal is under here. Everything to do with our receive signal is under there. All our results are grouped here, so they're easy to find. And then test is some very specific results and some very specific tests that customers need. And performance monitor is a kind of a calculation based on results. I'm going to go, I'll show them all in detail, but so they're all nicely grouped there. And we get into transmit settings. I'm actually going to run through, for the demo, I'm going to run through what all these settings are. And I hope it doesn't get too boring. That's what I usually do for a demo, and move it right along if people get bored. And let's see if I got a question there. I do have a question. How many, here's a question from somebody. How many of these PDH TCarrier modules can we put in a NIC Plus, NIC EP? Is this an advantage versus the competition? Well, it could be. in the world of NIC Plus, let me find a, I have to actually look in the price list to find myself. I don't know. I just heard a voice that says 4 or 5. I think it's 5. It's 5? Okay. So in a NIC Plus, I actually was just going to go to the price list and check myself, but since I've been told, maybe I'll just use that. Now let's look at the price list, and we know always what it looks like here. Okay. Hopefully you are seeing the price list. Make sure. Yep. So it says here, this is the section of the price list that's called NIC configurations. A11 module or A14 PDH TCarrier module says what it does. In the 2-slot chassis, which is the little NIC, you can have slot number 1 or slot 1 and 2. And C note number 1, which is, okay, for add drop, we don't need that. Okay, so it says you can have 2 in a 2-slot chassis and 5 in a 5-slot chassis. So actually that certainly could be a selling feature. For, I guess, manufacturing applications mainly, where they want to do multiple ports simultaneously, check out a lot of equipment all at the same time. They save time, they save money. We make money. Makes everybody good. So this would be a NIC Plus portable or a NIC EP rack mount. Can do 5. Okay. Now let's go back to the set itself. And let's see if I got another question. Here's another application. I don't know how to speak much about this. I'm just going to read the way it was written here, and then maybe hopefully you'll understand that. It just says wireless backhaul hyphen multiple T1s. So they can test multiple T1s. So I suppose that's what's used to get the wireless from their base stations back to the central switching offices. I guess they're using multiple T1s, and this way you can test them all simultaneously. I guess that's what that means, right? So that's another application. So you can look for wireless companies to sell these. Now, so I'm going to run through. I don't want to be too boring on what each one of these settings do. Please stop me. I'll try to keep the questions up where I can see them. But I'm just going to run through. There are some unique features. So first, so we're in transmit, so we're setting up the signal that we're going to send on our TX port. Settings control, it's coupled or independent. If it's coupled, then if I make a change on the transmit, it's duplicated automatically on receive. Nice little feature. If I go independent, I can set transmit and receive separate in certain aspects. And then termination, I think, gives me no choice. On this one, I can't choose, okay, that's because I'm on the E1 number 1, which is the 75 ohm. It doesn't have an option for termination. It doesn't have an option for balanced or unbalanced. It doesn't have any option, so I can't do anything with termination. And signal level, I thought I could, but evidently I can't do anything with the signal level on this one. I'll change to Bantam, and then we'll do signal cable in a second. Then line code, I have 2 choices. I can get into a vast explanation of these if you want them. You may regret it once I get started with it. It may be really boring. But it's alternate mark insertion, or HDB3. I don't actually know what that stands for. HDB, I don't know. But this one's alternate mark insertion. And it's just the customer's equipment is either configured for one or the other. They need to know you have both. Most customers will know exactly what it is, or at least how to use it. Now here's a unique one. Which very few people actually use, but it's a very unique, useful feature. Line frequency offset. So you're telling, it's a little out of sequence to me because this clock reference here, explain that. When you're doing a feature, when you're doing the demo, explain this one first. Clock reference and then line frequency offset. So clock reference is you're going to tell the test set to get its transmit clock either internally, so the built-in Stratum 3 that's in the test set, or the recovered E1 number 1. So you can have it get the timing from the signal that's coming into port number 1, or the timing that's coming into port number 2, just the regular old E1 signal, or bit sets, which is an external source within the central office, building integrated timing supply or source. And I don't even know what that stands for either. But anyway, it's an external port, and the connection for it is on the system controller on every NIC. So you choose any of those. When it's looped back on itself, when you're doing a demo, just to loop, always leave it on internal, just like that. So that was clock reference. And then above that, you have line frequency offset. So we told the test set to take your clock from one of these places. And then we're going to say, well, I don't really want you to follow that. I want you to follow that, but make it 1 part per million higher, or some number higher or lower. So now it's going to do, hope that makes sense to you folks. So it's not going to choose this really. It's going to go higher or lower based on what we told it to go. And that gives a stress to the network. It simulates what happens when they have something that's free running and doesn't comply with the clock of the network. Okay, and I want to show you I'm going to go to receive just for a minute before I get back to this. So I'll go receive sig for signal status, and we can see that, I'll just go ahead and show you this whole screen. We won't have to show it again later. This is the incoming signal. It's the positive and negative voltage. What's the power in dBm? Power in dB DSX. Line frequency. What it sees, it should be 2.048 meg. That's the actual standard of an E1. It's actually a little bit low, and it shows what the offset received is, which is right at what we told it, minus 50 parts per million on its speed. And we get back to here. Oh, got a definition, thank you very much. For HDB3, which I didn't know what it stood for, was high density bipolar 3. And again, if you want a little more explanation of what those are, I can get into it a little bit. I don't know if you need to know. Don't know if I should or not. So you let me know if you want more explanation. You can look it up if you want. I don't need to drag. Those who don't know it don't need to be dragged through it again, and those who do, good. Somebody says not necessary for me, good. Those who don't know it, it probably takes a little longer than the time I have to really, not that long, probably do 10 minutes, but we don't need that 10 minutes. And loopback, the tester itself can provide loopback. So if I put this now, it's either going to loop the line, which is the entire E1, or the payload, which is the rest of it except the frame. It actually can create a loop. Like if you had 2 test sets, one at each end of a circuit, you could put one of them in loop and then the signal from the first one, and it would go through the test set and come back. Okay. And framing, what choices there are. So these are the choices in E1 framing. Again, your customers just need to know that these are the choices they have because it needs to match the equipment that they're using. And we have mapping choices of bulk filled and fractional E1. Bulk filled is much more common. Your customers need to know you have fractional E1. Again, kind of just like everybody else has. But bulk filled fills the entire payload of the E1 with the pattern we're going to tell it to fill. Fractional fills only parts of the payload. And I'll show you how you do that. You do that with this section here. So once we chose fractional E1, and this is a pattern, whatever our pattern is going to be, and fractional E1, you see this pattern here. So there are 31 time slots in this particular kind of framing that we chose. And if we go, so I remember how to do this myself. Every one of these, every slot that has a 1 in it is going to have a part of the pattern. And every slot that has a 0 is not going to have part of the pattern. See? Hope that makes some kind of sense. So the pattern's only going to be put in those time slots, and the rest of them will be a null of some kind. Actually, they'll be the background, whatever's in here, the background 64K pattern. I think it's only an 8-bit. Yeah, it's only an 8-bit pattern. Now, I hope that makes sense without having to vastly explain that. Your customers will see that as a very easy way to set up fractional E1 or T1. Okay, and then pattern. We have all these available patterns. There are more patterns available in DS1 than there are here, so I'll show you the differences of that in a second. Basically, all these pseudo-random bit stream patterns, all the common ones, regular and inverted, all ones, just a series of ones, series of zeros, and user-defined. And you get a 32-bit stream that you just define yourself. If it's in hex, we can do any of these plus the letters. Easy as that. We've created our own pattern. Okay. And then the next thing is I'm going to pop over to receive just to show you that the settings of receive are kind of similar. They have a lot of the same things. We have settings control, again coupled independent, does the same thing as the one over in transmit. I still don't have an option on termination. I do have an option on cable equalization. So in this case it can be looked for, I want to describe this easily. So 0 dB is like a direct connection into the equipment. These others are for like a monitor port, like for active network. Often the cross-connect panel will have a monitor port. You can connect into that and receive a lower signal and it'll still work. And then framing type, same choices as transmit. Again, fractionally once, it's all the same. Payload expected, it's all the same. Difference is on transmit, we set the payload we're going to send. On here, we set the payload we're going to expect to receive. And again, here's how you set the fractional. E1, same thing. And the codec for how it handles the voice channels is selectable. And which 64K channel you want to drop, meaning that you can actually drop one single channel. Let's see if it'll do something here. And if there were an actual voice call on this channel, you could hear it on the speaker of the test set. Can't hear it remotely the way I'm doing it now, but if you were on the test set itself, you can hear it on the speaker of the test set. Okay, a lot of features and options in the PDH TCarrier rates. And then we get down into overhead, and we show the actual overhead that we're going to be sending. If you want to change something, you can actually just change directly. Let's do it that way. If it'll let me. So I can actually change what's going in the overhead. And all these spare bits, X bit, just change exactly what it is. It's very flexible in that way. It's a good selling feature. And then error and alarm is where I specifically send the errors and alarms. This is the same as our Sonnet or OTN feature. It's all the same. And the way it works, but the errors to insert are all different. Like if I want to insert a bit error, press bit, and at that point, just as soon as I've selected bit, I can go down here and just press error insert, and it says error insert completed successfully. And if your screen updates fast enough, you can see the little red bit error come up occasionally. Okay, and if I go over to results, I see that every time I click the button here, I get a bit error. Very easy to use. The customer's going to like that. And I come back over here. So that was just all I chose was the error type, and I just press the button to make it happen. I can also do an error insert rate. I can do 1 times 10 to the -3rd, -4th, -5th, or I can do a user defined and get a little more detail, like I can do 2.3 times 10 to the 4th power, for example. That's another little bit of a selling feature for all the NIC is some of our competitors will only do like 1 times 10 to the neg whatever, but we can get a little more exact on our rate. And then alarm generated. Let's just straighten that out. Let's bring that back to none. Set the error back to none. Alarm generated is just any alarm you choose. Choose to have an AIS, and it's going to just start sending it and send it until I turn it off. Okay, and now receive. We did all the settings already. And overhead is, it's a similar screen, but now we're looking at what is received, not what we're going to choose to send. Again, highly capable, has all the information you need. And SIG, as we looked at that already, also. So not much to see. So we've seen everything in transmit and receive on how you set up an E1 to transmit and E1 to receive. And somebody asked me, what does the acronym CAS mean? I think it's channel associated signaling. You know, I'm not 100% sure. Sometimes I don't get to, oh good. Yep, channel associated signaling. So again, I don't think, I suggest you just go look that up. We can get into a long explanation. And probably not what we should do here because I want to show you the basic features and how to demo it. So what I just did, hopefully a little more smoothly, is exactly how I would demo it to a customer. Show them the features, you know, and stop once in a while and say, this is a good selling feature, or this is a good feature for you. Like the few things we saw, like line frequency offset, that's a very good one. The fractional E1 if they don't have that one, and the ability to do error and alarms at a certain rate, 2.3 times 10 to the fourth, like I did. Okay, so now we're going to go to results. And results screen is really, if you've done our, if you looked at the training on how to do Sonnet SDH demonstration and OTN demonstrations, it's really the same. Our result screens are pretty much the same. I'll run through them real quickly anyway. So scan just gives me a list of everything that's happened during the current test since it was restarted. And we had some bit errors, we had all these alarms that I created for a couple seconds, 1 second, 5 seconds, so forth. It's just a kind of a summary. If I pressed restart, I would have, where's restart? Restart. And it goes back to no errors or alarms, I think. Yeah, no errors or alarms. That's a nice clean test. And then we have error down here. And it gives me all the available error types. What's the count since the test was restarted? What's the average rate? So the rate that the test set calculates since the test started. And the current rate is the rate in the last 1 second. And that's a nice feature because at a glance you can see if you have an error right now or you just had an error sometime during the test. And alarm is we have AIS, loss of frame, loss of signal, etc. All the available alarm types and how many seconds did we have them. Okay. An event is, it's everything that happened since the test started. Actually, I should get, let's get a couple things on here so we can actually see them. Okay, so the test started here at a certain time, 10:31:29, and then we had some bit errors, and then we had this alarm, and this bit errors ended, then we had the bipolar violation errors. So it just gives a list of everything that has happened during the current test. And you have this little button that says ascending or descending, so you can have the start test at the top, any of that. And if we stop the test, hopefully it'll tell me, yeah, end test. So then this can be printed, and it's very useful information to the customers. Nice feature. And no tracings on that. And then large LED just takes the same information that's over here on these alarm and status indicators and puts them on a larger plane so you can see it, if possible, just a bit further away. Okay. And then we have graph. And graph shows what happened over a period of time. So let's see, do resolution 1 minute. If I change the resolution, I think, to 1 second. Can I do that? Sample rate, 1 second. I still don't see what I had before. Change upper to bit counts. Well, maybe I have to do minute. Well, I don't know how to find those. If we're looking at, didn't we have some bit errors? I did, right? I Had a bunch of bit errors and some bipolar violations. So let's see. I can't get one of them to show me something. Well, I'm not sure how to get it to show the errors I wanted, but this should show red if, yep, not sure what I'm doing wrong here. If you know, you tell me. Because we're having, let's see what we're having right now. We're creating bit errors right now occasionally. Actually, we've lost pattern sync. What else did I change? Bad enough to have pattern sync. Well, I can at least see pattern sync. Let's go results, graph, change upper, alarm set 1, which has pattern sync. No, not sure what it's doing to me. But ideally, you're looking for red indications of what happened over a period of time graphically. Yep, not sure why it's not showing. Oh, you know why? Because I stopped the test. Okay, so now that we're running, I should be able to go to, let's change lower to bit counts, which we should have some. And it's on 1 minute, so it hasn't been running long enough. Let's go 1 second. Oh, finally. Gives me something I can see. So I have pattern sync lost there. And because pattern sync's lost, I don't have bit errors, which is fine. Pattern sync is what we're really creating. Not sure what I did that caused it to have pattern sync. All right, so that was all of results. Any question about results? Okay, and then test. Button number 1 under test says duration continuous, or you can have these preset times, 5 minutes, 15 minutes, 1 hour, and so forth, or go user defined up to, I believe the max is 99 days. I think that's about the max. I think I can do that. Oh, 28 days. What do I know? I'm thinking of an earlier test set. So 28 days is my maximum. And then you can choose what's the action after duration. You can have it do nothing, or you can have it print the current statistics, which means results, or record them on the test set itself. Or repeat actions, which means just do it again. And real-time actions, which gets into a whole other section. You know, actually, honestly, I don't remember how to explain real-time actions, so I'm just not going to try. We'll do that in the next time we do a sonnet or something like that. I'll explain the real-time actions. It's the same. I just didn't, honestly, I don't remember how to do it. And then service disruption is our next option, and that tells us you can have it look for a particular criteria, like when it starts getting bit errors, it starts a counter, and when the bit errors are gone, it ends that counter. So you can tell what period of time you had a disruption. It's a service disruption. And in this case, it can only do bit errors. Sometimes you have some options. And how long does it have to be good, or how many good frames does it have to require to be good again? And we can put it to state. Actually, let's get back to this normal condition, hopefully. We turn that off and restart the test. Okay. That's still not going to let me do it. Valid for key. Oh, you know why? Because I changed this pattern. So I can do a single APS. Automatic protection switching is what APS stands for, which is an actual common function of a service disruption. It's not the only possible function, but it's a common one, is when something switches from the regular line to the protect line. Now, so it says waiting for trigger. So it's looking for bit errors, if we come over here and we start giving it bit errors, not totally sure if it'll do it on just one bit error, but we'll try. We'll give it some bit errors and see. Come back to test. Okay. So it did it. It found a period of time, and it only did one. It only did it for the first time, actually. So it saw for one frame there was a bit error. That's the current one, the average, the minimum, maximum is all the same. I can also have it do continuous, which means it looks for multiple events of service disruption. I come back here and do this. Actually, I can keep it on the same screen. I just do it here. So I got one. I hit a bit error, and it had one frame, 0.125 milliseconds of a disruption. It's still waiting for another. So every time I do it, it's going to find another one. Now let's see if I can make this one longer. No, it just detects one each time. So, and the current one is the most recent one it found, and the average of all of them is all the same. Minimum, maximum is all the same. Okay, and then RTD is round trip delay. Like when you send a signal with the test set, how long does it take for that signal to go out to a loop and come back? And it's done just, I can do a single and continuous, kind of the way as before. Like it just does one quick test now. Or continuous, it'll just continually look for how long does it take. When it sends this pattern, how long does it take to receive that same pattern back? Okay, and then we get to performance monitor. Actually, let's turn that off. And notice that, by the way, it wasn't detecting on the pattern itself. When I turn this to active, turn to continuous, we got bit errors because it's actually sending bit errors occasionally, and that's what it's triggering on, is those bit errors. That's how it knows. The patterns themselves aren't long enough to do a round trip delay test because every pattern looks like another pattern and they repeat too often. Okay. Then we get to performance monitor. Now luckily, I won't tell you yet. So performance monitor, it takes the same results that are detected everywhere else. So errors, basically. And errors are sometimes alarms. And just does certain calculations based on international standards. These are the standard names, G.821, G.826, publications of the ITU, I believe. And it calculates error seconds, error-free seconds, severely errored seconds, and unavailable seconds based on criteria in the standard. And these are optional, what percentage you're allowed to use there, or what percentage you want to use. 100 is basically standard. And does on the frame errors basically, and bit errors. And this is just something that customers need to know that you have. Competitors have as well. This is not really a unique selling feature. It's a good feature. You need it, but it's not really a unique selling feature. And then, believe it or not, we've gone almost an hour just talking about E1, which is not my intention. I'm going to switch to DS1 real quick and show you just a couple of differences on DS1. Let's do Sonnet, DS1, DS3. Okay, this took much longer than I thought it would on E1. So keep that in mind if you're doing a demo. If you're going to show all the features, it's going to take a long time. So now everything is DS1. There really is not a huge difference in the way it's set up. We do have some things like, I still can't change that. I can change on the transmit signal level. And I have loop codes, which we didn't have before. In DS1, there are actually you can put these codes in the overhead or in the payload, and it causes customer service units and other equipment at the end of a line to loop up. You can use the test set to command a loop and create a test that way. Customers do use that, particularly carriers. This is carrier function. And I don't have one really set up that I could show you. If I set two test sets together, I could have one cause a loop in the other one. Because if I turn this auto response to on, if this one receives a proper loopback code, it will loop itself. It'll give a loop to the other end. Okay, there's that feature. And everything else is really very similar. We do have a little bit of a DS0 feature to see in this one. You can actually look at individual DS0s and their value. Again, we have speaker on and off. This a similar function to what we had in E1, just done a little bit differently. And in this one, we can go, where's all channel? So all channel, I can actually look at the signaling bits of all 24 channels simultaneously. There are 24 channels in a DS1, 24 voice channels. Okay, and then in our very brief 8 minutes, because we never go over, as promised, I want to show you very quickly DS3 and E4, because the layout is not different. There's really not so much to show in terms of layout. The exact technology is a little bit different. Let's see, like framing is different. But the setup is the same, results is identical. Actually, I said it's identical, but it's actually laid out a little different because these buttons were over here on the other one. Here, they're here. Errors and alarms are up here now. Okay, test, same functions. Performance monitor, same except less to see. E4, it's more similar to E1 actually, but it has a little bit. No, that's laid out in the same way. Not sure why they're different. Same functions, just the buttons instead of being over here or over here. And then the one thing important to remember, so we have this E4. You know, we can restart a test on E4 here and let it run, so it's starting there. Over here on DS3, that test has been running for 3 minutes and 17 seconds. Over here it's been running for 2 minutes 13 seconds. Over here it's been running for 2 minutes 11 seconds. They're all independent, simultaneous. Okay, that's a very important thing to remember. And I want to show you something because I kept telling you that our drop and insert function is important. So you see this test set has a Sonnet module of some kind. I believe this is an MSA module. Yes, it is an MSA module. And over in Sonnet, I think you just lost my image, didn't you? No, maybe not. It says you did. You lost the live image. Okay, to be back. All right. Over in Sonnet here, I can do. Let's do an interface of like OC48, and I'll show you I can drop to. I go mapping. I can drop down to this VT 1.5. Well, actually, I can't even show you from here. I have to do it this way. Sorry. I have to do a preset. Okay, I can do a preset from OC48 and configuration all the way down to either DS3, well, actually E4. E4 add drop, DS3 add drop, or either one of the DS1s. And add drop means it's going to drop down to the built-in DS3 or DS1 or E4 test set. Add drop line interface means it's actually going to drop to the external port. Hope that makes sense. You're going to take in an OC48 optical. It's going to pull the DS1 out of it, and it's going to put that DS1 signal out of the test set. So it can be, you can put it to a piece of equipment, you can put it to more test equipment, higher level test equipment, whatever you wanted. Here's a common one. We're just going to do this one. DS1 add drop. I'm going to apply it. And then I'm going to go to the switch matrix. Hopefully you've all seen the switch matrix, and just show you how it connected. So with that preset I did, it started here at the physical layer, OC48, went down to STS1 number 1, which you could change in the menu, down to VT number 1, and down through here straight to DS1 number 1. Okay, and there are many other ways we could set it up. We could go OC48. Let's just be different. We'll go OC12. That STS down to this M13, down to this DS1. So we have a lot of options there, and apply. So you see what we're doing? It didn't do what I said it would do, did it? I've confused myself somehow. Well, I only have 3 minutes left, but the idea is you can do, if you see there's a line here like E4, goes straight to its own line interface, so that's an independent test going on. This one is on its own line interface. And somehow without really meaning to, I set up DS3 going through this M13 mux and down to a DS1 number 2. So there are all these simultaneous going on. And with less than 3 minutes left, I want to open it up for some quick questions, and then we'll get out of here on time, as we always do. Let you get back to work. So who has a question? None? Nobody? Cool. That's fine if you don't. We'll just we'll end off then, and I'll wish you a very productive week of selling. We're going to do some more questions of these. We're going to do more of these training classes coming up. Have some good ones that you're going to find out, and some new features and that sort of thing. This is kind of a very old feature, and it's not one of our more expensive features, so it's not terribly exciting. And it's been around for a long time, and most of the competitors have it. So it may not be that exciting, but if a customer wants it, then you need it. Well, here's one question. How much of a market do you see for these features today? You know, honestly, there's not a lot of new network equipment that's going in that's centered around DS1s and DS3s, E1s and E3s, but it's still out there. We sell an awful lot of equipment that's like Sonnet SDH, but it'll also have the PDH TCarrier module in it. We do sell a lot of them. So I don't have numbers of the market. Nobody's really paying great attention, and it doesn't get a lot of news coverage, the DS1 market. But it's still there, and it's not an expensive add-on, so it's added on to a lot of test equipment. If anything, you may just always, if somebody's really looking for Sonnet, you just may want to mention, you know, well, inexpensively, you could have this combined in your test set as well. So, I don't know. Wish I had a better answer for what the market is. I do know we sell quite a lot of them. Well, I think time's up. We made it all the way for a whole hour for a change. And I hope I can answer any questions. If you think of a question later, just ask. But so this is it. Y'all have a great day.